No, I'm just kidding. I'm kidding. The audio does work. What's going on, folks? How's it going with you? I don't know why we have like 3 people attending the class. Like, what's the deal, folks? In fact, I'm talking to you, people watching the YouTube video. You. I keep talking to like my picture, which is off. Like the video, because I think the video camera's like right where the picture is, but the camera's right here. You. I'm talking to you. Where's everybody? Like Ted just showed up. So it's 9:30. Let's get this party started. I'll tell you what. I think what I'm going to do is I'm going to start using this thing called the quadratic equation, and then when more people get here, I'm going to prove it to you guys. I wanted to start with proving it to you, but there's no point in proving it to you because I proved it to you on Tuesday, and then I'm waiting for everyone to show up so I can prove it to you today. And if I prove it to you with 4 people instead of 5 people, and one of those 4 people have already seen it and actually enjoy it, like that, that proof and whatnot, it's really hard. It's a difficult proof, and it took me an hour and a half just to get through it. And I did it in baby steps. So now you guys got to put on your big boy pants and just kind of. So, what did Calhoun say in Wreck-It Ralph? They're like, it's time to put on your big boy slacks. Nope, and no PP in the.
I haven't seen that.
Oh, you haven't seen Wreck-It Ralph?
No, I haven't seen it for a while.
Oh, it's a good movie, Wreck-It Ralph. All right. Anyway, let's do some examples. Let's start off with that. How's that? So turn to page I don't know. I think it's page 5. And it looks like they do example 1 for you completely. Why don't we do example 2? All right. Now, boys, we just showed up. Let's start the class off like this. There's this equation that we called. All right. So.
Oh, you gotta tell them the story.
All right. I'll tell you the story. I'll tell you the story after I.
When you explain it.
After I explain it. Okay. So, we've been solving problems that look like that, right? We've been solving those kinds of problems, and those are called what kind of problems? They're not linear. They're they're called quadratics, right? And how do we identify a quadratic? This is like the first thing I ever taught you was how do you identify a quadratic? You can kind of tell because of that square term. That square term makes it a quadratic. If there is no square term, then it's not a quadratic. And the shape of that graph would be a line, most likely. You know what I mean? If that 3x squared wasn't there, then you have a negative 5x plus 1, and that's just a straight up line.
Yes.
Yeah, it'd be good for you to be here. Why would you not want to be here? No, we're not going to do the exact same thing. We're doing a lot of different stuff. But I will prove. All right. So Brandy's saying, are we going exactly over what we went over on Tuesday? And the answer is absolutely not. But I will, at some point, when everyone else shows up, prove the quadratic equation again because I really hate the concept of the 3 people who are new who just showed up here. Well, no, I mean they're different. They didn't come the last time. They haven't seen me prove the quadratic equation, and I hate to just kind of pull this equation out and say memorize this, but I'm waiting for everybody else to kind of show up and say where are you guys and what's going on. All right. So anyway, what we've been solving is we've been solving these kinds of problems: the 3x squared minus 5x plus 1. The thing is, because there's an x squared term, we know that it's a quadratic, and we know that the shape of that graph looks like a what? Or is called a what? So it's with a P. You can say it. A parabola. Exactly. Yeah. A parabola. And yeah, it's definitely some kind of virus. It's a parabola virus. And it kind of has this U-looking shape, right? Like the perfect way to describe it is to really just throw a ball up in the air and then have it come back down. See that shape right there that I make? That's a parabola. That is exactly a parabola. That actually kind of defines a parabola. In fact, the reason why we want to look at what a parabola is and we want to find out all of this information is because we want to solve stuff like this. And the world, a lot of the stuff in the world act like that. What are you guys listening to?
Mucus.
What?
Music.
No.
Very, very tired.
No, you are not listening to music. No. Take out the headphones. Not allowed. Not in my class. All right. Anyway,
I know.
There we go, Adriana.
Like, really.
Thank you, Adriana. She just showed up. All right.
Hi,
Anyway.
Adriana.
All right. So check this out.
Brandy says hi, Adriana. Oh wait.
We've been going about this in two different ways. I've taught you two ways to solve quadratics.
Love you, Adriana.
The first way is I've taught you two ways to solve quadratics using this form. And by the way, I'm paying attention a lot to people online. That doesn't mean I'm going to burn these two students over here. What I mean by that is I'm not going to hold you accountable. I mean, I am going to hold you guys accountable. But I want you guys to answer me online and whatnot. I don't ignore you and I don't forget you. The point that I'm trying to make is, like, when we have something in standard form, that thing, we've taught you two different ways to solve these problems. One is called factoring, and the factoring is where you put these two big parentheses, right? And then you break it up and you try plugging in a bunch of different numbers. And really, I think that the thing is, it's a game, right? It's just this kind of thing where you just kind of like try out a bunch of numbers, and if it works, it works, and if it doesn't work, then move on to a different set of numbers, right? The problem is, it doesn't always work. And in fact, I'll tell you when it works. It works when your parabola falls perfectly on two nice numbers. Okay? That's when factoring works. It's when the x-intercepts are like pretty, like just whole numbers straight up. If they're whole numbers, then you could have solved it using factoring. If they're not whole numbers, then it would be really, really difficult to find it using factoring. It wouldn't be impossible, it'd just be really hard. And so the way we approach that is to say, okay, well, factoring is a really nice, quick, elegant way, but it doesn't solve every problem. Let me show you a technique that solves every problem. And the technique that solves every problem is this thing that we called completing the square. We spent 2 weeks talking about it. We spent more than 2 weeks, like 4 weeks, talking about how to complete the square. And that's like our bazooka. That one thing will shoot it down every single time. It will always work. Garance Bobarance, no questions. Okay? What I did yesterday was I showed you a third technique. And this third technique isn't actually even
the day before
on Tuesday. When I showed you last class, is
Wednesday, bro.
Wednesday. When I showed you last class was this third technique. And this third technique is actually, it's not really even a third technique. It's actually doing the exact same thing as completing the square. You're just kind of doing it in one giant step. Does that make sense? Online? Come on.
Did it get to?
All right. So here's what I need you guys to do. Write this down. 3x squared plus minus 5x plus 1. I'm sorry, Ted. I'm going to mute you. You're what? Huh? What's going on? Oh, I think he's talking to someone else. There we go. All right. So 3x squared minus 5x plus 1. Write that down. And what we're doing is we're comparing this to a very general standard form. And the general standard form that we're looking at is ax squared plus bx plus c equals 0. So that looks terrible. Let me write it. Let me kind of make it look a little prettier. That was ax squared plus bx plus c equals 0. Now, we know that x's are variables, but a and b and c are also variables. They can be any number you want them to be. They're still numbers. We just put a letter in there to represent, like, it can change that number. And in this particular case, if you compare a, b, and c to those, to the equation that you have in black, what is a? I want somebody online to answer this. Anyone online. Okay. John says 3x squared. That's not a. The 3 is the a. The x squared, see, if I compare these two to each other, the x squared is still there. You see what I mean? But the number that a is 3. Exactly. So a is 3, b is negative 5. Exactly, Ted. You don't need to include the negative 5x because, we're just looking, The b represents what we call the coefficient. It's the number in front of the x. The a represents the coefficient, the number in front of the x squared. The c is all the other junk left over. Anything that doesn't have an x in it. Does that make sense? So the c in this case is 1. Are we cool with that?
Yes.
All right. Now, yesterday, or not, last class, I taught these two, because you guys weren't here, but these two,
Brandy and Diamond.
an equation that once you identify A, B, and C, all you got to do is plug this into this equation. Do you guys remember this equation? It goes like this. X equals
a negative boy.
negative B. Do you remember?
Wait, yes I do. Was unsure
Plus or minus
if he was going to go to a radical party or
square root
not. He ended up going, and he was a completed square, or a square.
B squared.
And he missed out on on meeting 4 awesome chicks.
4AC.
And the party ended at 2 a.m.
2A. There we go.
Such a wonderful thing, I just can't.
You got it. Negative B plus or minus B squared minus 4AC all over 2A. So all you got to do is just take, okay, what is A? A is 3. What is B? B is negative 5. What is C? C is 1. And all you do is plug those numbers in. That's it. Plug it in, plug it in. I don't think that's Febreze. I think that's the, like it's...
Ted is just...
Yeah. Anyway.
He's just Ted.
All right.
The nicest way.
So, the way you look at this is the negative B. What is negative B? What is negative 5? What is negative 5 is actually a secret code for
Positive
5. There we go.
What? Did you just say? I did.
All right. What is negative 5 squared? Actually, you know what? Let's just skip what they're telling us. All right. So negative 5 is positive 5. Then I got my plus or minus, the square root of what is negative 5 squared? Positive 25. Got it? All right. Minus 4 times A times C. Look what A is, look what C is, and multiply that by 4. Multiply all that together. 4AC. What does that equal to?
12. Negative.
So it's minus 12.
Over.
All right?
6.
And then you divide that whole thing by 2 times A, which is 6.
Here, I have a question.
Yes, your question.
Never mind. Ignore that question. I
All
just saw it.
So, this is 5 plus or minus the square root of 13 divided by 6. That's what your answer is. That's literally, I mean, you stop there and you say, that's what my answer is. I mean, you could, if you wanted to, calculate out some numbers. In fact, let's do some Desmos work and see if that works. All right. First thing I'm going to do is, we don't know what square root of 13 is. It's not a pretty number. It's not like the square root of 16. That would be an easy number to take the square root of, right?
Google background makes me laugh.
The square root of 16 would be an easy number to take the square root of, right? Or the square root of 9. But 13 is not a nice number to take. But it is a number, right? There is definitely a number that the square root of 13 is. It's some kind of ugly decimal.
Google
In fact,
it. When in doubt.
square root of 13 is 3.60 blah, blah, blah.
3.61.
All right, 3.61. So all you do is you say, okay, well, what is 5 plus 3.61? I got to divide that whole thing by 6. So I'll just put divide 6. All right, so write this down for me. It's 1.43, it looks like.
1.43.
Or 1.44. All right, and then we'll put 5 minus 3.61, because it's both plus and minus. There's two answers, plus version and the minus version. So the other number I want you to write down is 2.31, or yeah, 0.2, or 0.23. Yeah, that'd be good enough. All right, then what we're going to do is I'm going to go over Desmos. All right, And then I'm going to graph this thing right here. 3x squared minus 5x plus 1. All right. Let's look at where it crosses. (0.232), right? 1.43.
Oh, boom.
That's right. I picked up a pencil and dropped it.
Table.
Yeah. Boom. Bam. That's right, suckers. Look how cool that was. And obviously, this wouldn't have been able to be solved using, I mean, you can kind of tell that this wouldn't have been able to be solved using factoring. Because if it were able to be solved using factoring, then this number right here would be some kind of nice number. Like if it were the square root of 16, then that would just reduce down to 4, and then we would have known, hey, we could have probably solved that using factoring.
Yes, we can, John.
Yeah, but like
Yes, and in fact, all we're going to do today is we're going to prove, or we're going to show you how to use this equation. So I want you to I want you to memorize this equation, and I'll tell you what. Why don't I tell you the story about it now? I'll tell you the story on how to memorize it first, and then.
especially the story.
But
Definitely said the story.
I said the story.
They
Just say it again.
didn't hear the slow version, or they didn't hear the full version. All right. So I want you to write this down. Everyone, take out a piece of paper. X equals I'm serious. Like,
this is beast.
I got a question. When I tell you to write things down, do you guys actually do it? Or do you guys just kind of like,
Okay, I'm gonna be honest.
Okay,
I'm gonna be
Mr.
honest.
Dalday, I'm
Sometimes
writing
it
it down.
Okay, she's gonna be honest and say sometimes. I'm gonna be honest and say
No.
most likely not.
Yeah.
It's like, okay, Mr. Dalday. Uh-huh.
She's dying.
Uh-huh. Oh my gosh, Nicki Minaj. That's what you guys do at home. Yeah. Write this down. X
Oh,
equals,
crap.
hey, X equals negative B plus or minus. That's what the plus on top and the minus on the bottom means. The big square root, B squared minus 4AC, and put a big division sign under the whole thing and put 2A on the bottom. All over 2A. Okay? All right, that is called the quadratic equation. Now, let me tell you the story about how I memorized the quadratic equation.
I don't know how I memorized it, but I did.
All right, so
Okay.
the story goes like this. There was this dude. He was a boy. Sorry, it has to be a boy. He's kind of a negative guy, right? He's a negative boy, and
Technically, it doesn't have to be a boy. So
what is that?
it doesn't have to be a boy
Why doesn't it have to be a boy?
because
It has to be a boy.
It has to be a
'cause
boy.
It's B. Boy
it
B.
could be anything. Could have been girl talking
Okay,
to a
there's
girl,
this
man.
girl named Brandy.
Yeah.
All right.
That's right.
There's either a boy or a girl named Brandon.
My last name is Borges.
Okay,
so-
all right. So there's somebody who has a B associated with them. Please stop distracting me with that kind of stuff. All right. There's a boy, and he's kind of a negative guy, and he was invited to go to this party, and it was awesome. Well, he was, but see, the thing is, he was unsure whether or not he wanted to go to this party. Okay. But it was a radical party. It was like super radical. I don't know how to change that word. It was a radical party. Okay. And this boy was kind of a square. And I don't know if what does that mean to you guys? Like, does that like exist in your lingo nowadays, or just not?
A square?
Like, we don't. Yeah.
Or red.
Do you ever call people like, "Oh, you're such a square"?
No. Unless their head
Stop
looks
being
like a
such
square.
a square. You guys don't ever say that?
No.
All right, I just wonder. All right.
There's this guy that I know, his head is like in the shape of a square.
All right, fine. So
just tease him,
So
call
he
him
was kind of a
SpongeBob.
square, right? And apparently, there's this guy that she knows that his head is in the shape of a square,
So
which
we call him SpongeBob.
which I would say isn't very attractive, right? Like
It's not.
a square head is not really that attractive. So because he had a square head, and can you visualize in your mind this dude sitting at this radical party and he's got a square face? In fact, let's say he's SpongeBob. I'm sorry. Yes, I'm going off on tangents. Yes, go. What's up?
If somebody is trying to tempt another person to take drugs,
Yeah.
but the person is refusing. The person who refuses to take drugs is called a square.
Okay. All right.
And I hope everybody in this class is a square.
I can hang with that. Like, so most people would call, like, I think that square to me means like prudent, like you're so boring. You know what I mean? You're not exciting.
Huh?
That kind of stuff.
Not
Which is not. Which I'm totally a square. I'm totally boring,
He's not.
exciting, or not exciting.
You're not.
I-
boring.
No, but I mean, like, I've never done drugs.
That has nothing to do with it.
Yeah. Well, anyway. All right. Don't do drugs, kids. That's the moral of this lesson. All right.
Moving on.
Because he was a square, he missed out on talking to 4 awesome chicks.
2 over here.
Yeah, 2 of which
Perfect.
are hanging out. I don't know where the other 2 are.
That's
There were
nice.
4 awesome chicks.
They were sick today.
All right.
They're taking a sick day.
Well, one of them.
And this
died.
whole party
So
was
we drove.
over at 2 a.m. Okay, let me give you the recap of the story. Negative boy, got it? Unsure. Radical party. Dude was being a square. Missed out on talking to 4 awesome chicks. The whole party was over at 2 a.m. You guys got it? You got the story?
So walk them through it again and like,
Okay.
but like you know where you're referring to.
So what I'm talking about is when I tell you about the quadratic equation. Now, I think it's kind of interesting whenever parents like over listen to the my WebExes while doing this. They're like, "What is your teacher talking about? He's talking about
My dad.
drugs and awesome chicks." And man, I'm gonna have to have a talk with this guy. All right.
Dad probably bust laughing, be like, "That's a good one." Oh, I told him the story yesterday. I
Okay,
used to eat Burger King.
So we have x equals
I wrote it down for them.
a negative boy, unsure, plus or minus. Radical party. A square root is also known as a radical. Dude was being a square. Missed out, minus, on 4 awesome chicks. The whole party was over at 2 a.m.
Yeah.
Now keep in mind that what's going to happen is sometimes you'll see it as this. The book writes it as this.
And that just screws me up.
Okay, the book will write it as the one on the bottom, where they put the
Yeah.
2a on the left one and the 2a
That's
on
right,
the
the
second,
line.
That
the
just
second term.
screws me up.
And the way I write it is I just put the whole thing over 2a.
Which just makes so much more sense.
To me,
It does.
the reason being is
And then the
because
story makes so much more sense.
2a and 2a on the bottom, they're the same denominator. And if they're the same denominator, you can combine those 2 fractions. So I just write this as this, you know what I mean? Alright, anyway, let's move on. Let's do some more practice with this stuff.
Mr. Dalday, look at my video chat.
You have a video chat. What's a video? Oh,
It is video.
oh, you want me to look at your face? That's what you're telling me. Got it. All right, fine. We'll do it. As long as it's something appropriate.
Look at it and get jealous.
Ted.
It smells delicious.
You know what? I was eating Portuguese sausage this morning, so
Ha!
Hey, do you want to buy some?
yeah, bacon is
Do you want to buy
You
some?
can't.
We
You
made
can't top bacon.
Oh,
I
yeah?
don't like bacon.
homemade kind. Oh, I might need to try some of that.
Smokehouse.
Ooh, wow. Oh, yeah. All right, let's go.
I will
Let's do
hook
this.
you
All
up.
right, okay, ready?
Bacon for
All right, so check this
I
out.
don't like it.
Here's what we're gonna do.
I don't think that's physical.
X squared minus 6x plus 9.
Oh, moving on page.
First
6.
thing I'm going to do is I'm gonna try to factor this. If I can factor this, then I don't need the quadratic equation. Because like I said, quadratic equation
7.
always works. It's our bazooka. It will work. Garens Barons. The problem
Okay,
is
why do you say that? Where did that?
really? You guys don't know?
Bazooka or Garen's Barons?
Garrett's Blueberries.
Oh,
bro,
Garen's
bro,
Barons
where
is
have
kind
you
of a
been?
yeah, like
Where have
that's
you
kind of a
been?
local thing, I think. Anyway,
I don't know if
All
you
right.
noticed, but I'm really white.
yeah.
I don't know if you've paid attention.
Okay, well, you live in Hawaii, so
I
deal with
glow
it.
at night. I grew up in Florida until
Did
I
you
was
say you
10.
glow?
I glow at night.
All right. Anyway, hey,
I'm white because the sun reflects off of me.
that was funny. All right. the quadratic equation, complete the square, always works. It will work regardless. It's kind of a pain, I admit. And I'm totally not saying that, you know, it's not. It's not easy at all. I admit to that.
Wait. I'm telling my mother that you want to buy sausage, so I don't forget about it.
All right, fine. All right. It's kind of it's kind of tough to deal with it. There's a lot, you know, it's pretty big, I admit. And so factoring is the quicker way. Factoring doesn't always work. So why don't we try factoring this? If factoring works, then we stop and we just move on to the next problem.
For real?
Yeah, that's it. Because you solved it. If factoring works, then you can solve it.
I didn't know that.
But, so let's try this. We put an x here, we put an x here. We're going to have a minus and a minus sign. You guys agree? I'm just trying to factor this.
Yep.
What two numbers can I write down? 3 and 3, huh?
Psst, people
Oh.
online. 3.
Oh, I'm done. I mean,
You're done.
Or you could do.
well, I'm done. I mean, here's what the answer is. X minus 3 equals 0, or x minus 3 equals 0, right? Because remember, factoring, when we set this equal to 0, either the first one equals 0 or the second one equals 0.
Don't you have to?
And then you have
put the
x
square
equals positive 3, or x equals
positive 3.
positive 3.
Do you have to put the
Shoot, you're done. That's it.
the x minus 3 squared?
Oh, I mean, you could put the x minus 3 squared equals 0. But what I'm trying to do, the whole point of this game is to solve for x. Right?
Oh.
You guys get it?
Gotcha.
I'll tell you what. At this point, don't write anything down. Just watch me.
Awesome.
All right? No, I mean, just for the rest of this problem, don't write anything down. We're done. You technically, if you could solve this by factoring, we finished it. But I'm going to show you the quadratic equation, and it might be like, okay, this is the overkill way of doing it.
Oh my god.
But I want to show you something that I think is cool. Okay? So just watch. All right? Everyone watch. In this case, A is 1, B is -6, and C is 9. Right?
This goes to like 11, dude.
Yeah, class goes to 11, and I'm gonna stick to that because I want to show you the quadratic equation. You can leave, Jonathan, and that's fine. But I'm gonna go to 11, and then you can watch the rest of the archive because this is important stuff, man. All right.
I'm so glad we have
So,
this stuff.
A is 1, B is -6, and C is 9. If I were to plug that into the quadratic equation, and it goes -b plus or minus, I'm just writing it down. -b plus or minus the square root of b squared minus 4ac all over 2a. I've only memorized this just because I've been doing this a long time. Anyway, the -b is +6, right? Because it's -6. Plus or minus the square root of 36, got it? Minus 4 times a times c. What's 4 times 9 times 1?
That's 1 times 9.
All right, you're 4 times 9, really.
36.
It's 36.
Oh,
All over 2a, so it's just 2, really, right? 36 minus 36, that's 0. So you got 6 plus or minus 0. Well, you can just cut out the plus or minus, because, I mean, if you're adding or subtracting 0, it's not going to do anything. And you got 6 divided by 2, that's just 3. X equals 3. The quadratic equation
that's so much
showed us the
easier.
same thing as factoring.
That's so much easier.
Which one is? Quadratic equation?
No, but like when you showed that one to us where it could be completely factored,
Yeah.
that just looks
Oh,
so
yeah,
much
yeah,
easier.
yeah. It's so much easier because the
That's
numbers
exactly.
ended up being nice. You know what I mean? But for the most part, like, so what I'm saying is when you take a look at a problem, don't think that the quadratic equation is the best solution. It will always give you a solution. It will always work. It just might not be the quickest way to get there. Because to me, the quickest way to get there would be looking at the factors. Just factor it. X minus 3, X minus 3. Oh, X equals 3. Got it. The problem is, like, so, I mean, there's two different approaches. If you feel like you can look at a question, and I'm telling you this because, like, for standardized tests, for testing, when you look at an equation, if you feel like, I don't know how to start this, I don't know what I'm doing, then use the quadratic equation because I
Don't
guarantee it
scare
will
me.
work. Right? It will take longer, but it will work.
This one?
Yes.
I just realized it looks like a
It's just a
telescope.
No, it looks like a caramel one.
All right.
Oh.
All right.
Terrifying.
Let's try this one. Are we cool with that? Like,
Yes.
did you guys see how powerful that quadratic equation is? It works on the easy stuff and the hard stuff. Although if there's an easy problem, I would recommend solving it the easy way. Sound fair? All right. You want to try factoring this or no? 2x, x. Let's see. Is there a number that I can make? What are the factors of 6? It's 2 and 3 and 6 and 1, right? Can I make that end up being 3 in any way? If I have a 2 and a 3, that wouldn't give me. If I have a 6 and a 1, that wouldn't work either.
Wait, what are we trying to get?
I'm trying to get 3 out of this thing. I don't think I can factor this.
No.
Like, it cannot be
because
factored.
you have the 6 on the end.
All right, fine. Let's identify. Then that route is out. Okay. Tried factoring doesn't work. Quadratic equation. Brandy, I want you to tell me what. Well, you know what? I want someone online. Tell me what is A, B, and C. John says
John.
A is equal to 2.
John's on.
Agreed. B. B is equal to.
Ted.
Come on, Ted. Hit it. Kingston, Adriana. B is equal to -3. Someone's got to beat John on this next one. C is equal to -6. Sorry, John's got it.
Oh.
All right. 2, -3, and -6. I'm going to write down the quadratic equation. And I would recommend for you, when you're doing your homework, write it down every time. Because the more you write it down, the quicker you're going to get at it. And you won't have to tell yourself the story every time you write it down. It's -b plus or minus the square root of b squared minus 4ac all over 2a. And that's x equals.
And I told
We
it to
identified
Harris.
what A, B, and C are. Let's plug it in. This would be -3, which is known as +3. Plus or minus the square root of b squared, which is 9.
Yep.
Minus 4 times 2, 8, times 6. What's 8 times 6?
48.
Yeah.
48.
Oh.
48. But it's, wait, here, look at this. It's 4 times 2 times -6. So what is that?
-48.
-48.
Sorry, I didn't hear the negative part.
But look, see how it's a minus -48? That actually
Oh, it's a
becomes
positive.
plus 48.
Yeah,
Do you guys see that subtle
I do.
thing?
I know how that.
Does that make sense to you?
Much subtlety.
And I'm going to put that all over 4 because 2 times 2 is 4. All right, so I have 3 plus or minus the square root of what is 9 plus 48?
57.
Is it 57?
67.
Yeah, it's 57.
Boom.
Over 4. There we go. That's your answer. You're done. 3 plus or minus the square root of 57 over 4.
I hate these numbers. These
No, I actually like these numbers because you know what? If this thing were a squareable number, then you'd have to deal with it. But at this point, you're like, all right, I can't really simplify that. I'm done. Okay? So right now, John, all I've done is like shown you like this thing, and I'm saying, here's the equation, use it from now on. I want to have a chance to show you where it comes from. In fact, I think I'm going to take that opportunity to do this now. Where did I get the quadratic equation? And it might take me about 10 minutes, all right? I spent an hour and a half doing this. I want you to, for those of you who weren't here yesterday, which is everyone online, I want you to write this down.
And your brains are gonna hurt.
And I'll admit to you, now please, keep this in mind, okay? Here's what I want you to keep in mind. Do you think the quadratic equation is easy?
No, but I like it more than I like factoring.
Yeah, I kind of do like it more than I like factoring. But do you think that a quadratic equation is worth learning?
Worth learning?
Yeah.
What you said? Yeah.
Probably considering I'm never going to use it in life.
No, you totally will use this in life because
Really? Can you give
Lots
me
of
like an
things.
example?
okay,
Of a
okay.
not office job.
Would you use it as a veterinarian?
Yeah,
Oh my god.
you would use it as a veterinarian because what you need to do is when you look at like medicine and like how much medicine will affect an animal and whatnot, you want to calculate like take into account their weight and all of that kind of stuff. And sometimes, a lot of times, a lot of times the graph that you'll see is a curve. And that curve can be represented by a parabola, and those parabolas you want to solve exactly where those things land. If not, you're going to overdose your puppy, and you're going to kill puppies. You want to kill puppies?
You want to kill puppies?
Like,
I didn't say that.
I'm just saying, like,
I'm going
okay,
to
fine.
save them.
Be a veterinarian
I'm going to save them.
and don't learn math, you puppy killer.
Like a string.
Yeah, there's
I
your
happen
mo-
to have 9 at home right now, and I'm taking very good care of them.
there's your motivation to learn math. Don't kill puppies.
Well, I can
Learn
what I want to be
math.
as I need this.
Let them live.
I know.
Save them.
I know.
Puppies.
I'm pro-life puppies. I'm also pro-life humans, but I mean,
I'm pro-choice. Hi.
hi. I don't like killing puppies.
Hi.
What is that?
Nothing.
It's not your body.
I never said that.
What does my body have to do with puppies? You like killing puppies? Alright, anyway. Alright, anyway.
I will have a pro-choice argument with you.
Alright, anyway. Here's what we got. Now, write this down. I'm going to use a different color. I'll admit to you, and I'm going to tell you right now off the bat, this is going to be intense. This is how I came up with the quadratic equation. And yes, I said I came up with it. I didn't. I'm lying to you.
Oh,
Somebody
with him,
else
guys.
came up with the quadratic equation. Let's do it. Okay? Ready? All right. This right here is called the standard equation. It's the standard version of our form. It goes ax squared plus bx plus c equals 0. We've solved this problem many, many times. We just haven't solved it with an a, b, and c. We've done it with numbers. Okay?
Give them the warning that their brains are going to hurt.
You're right. Your brains are going to hurt. But I want you to follow along with this because here's the thing. I want you to see where it comes from so you know I didn't poop out the equation, throw it up on the board, and say memorize this for the rest of your life. I want you to know that this is not magic. It's not even stuff you haven't learned. It's totally stuff you've learned. What I'm going to do is this thing called completing the square. Do you guys remember completing the square? You take that middle number and you do what to it? You divide it by 2, you square it, and then you add that, extra bit to the equation. But then we went through that whole process of but we can't just go around adding stuff, so you subtract that same amount of stuff at the end. That's all we're going to be doing, okay? All right, so let me start. Ax squared plus bx equals c, or plus c equals 0. Anyone confused yet? And here's what I need from you. I need the people online to say good, or, I'm following you, okay? So, you guys ready? Say yes, or good, or cool, or whatever. I just need responses from you. All right.
From everybody.
Yeah, I need, yeah. And even if it's even if it's like saying yes, like,
Sure.
tell me something, all right? If you're confused, tell me that you're confused. I'll try my best to explain. Okay, ready? Ax squared plus bx plus c equals 0. What I'm going to do is I'm going to do completing the square, but the problem is we don't know how to complete the square when there's a number in front of that x squared term. Yeah?
Uh-huh.
Yeah, all right, fine. Eyes roll works. All right, so what I'm going to do is I'm going to factor out that number. So I have a times x squared plus b over ax plus c over a equals 0.
Sharpie.
If you don't believe me,
You do need Sharpie.
distribute that a back in there to each term, and you'll see that I didn't change anything. If I distribute that a, it will be ax squared. If I distribute that a into the second term, it will just be b times x. And if I distribute that a into the third term, it will just be c. All I did, and the reason why I did this step, is to take out the a in front of the x squared term. I don't like that.
Why not?
Because I don't know how to complete the square
Yeah, well, eight
with
is
that.
not
With
there.
that there. Okay, I got you.
All right, we good? Say good, bad. So. All right, okay. Second thing I'm going to do is I'm going to rewrite this equation. And I'm not even going to change any of the numbers. All I'm going to do is I'm going to put some random spaces. Ax squared plus b over ax
Wink, wink, random.
plus c over a equals 0. I didn't change anything. I just wrote it and I put some spaces there. Now, I'm going to tell you why I put the spaces. The reason why I'm putting the spaces is because I want to use the technique called complete the square. And I know that you guys know this. I know that, Adriana, I actually know that you're really good at this because I remember, like, I was watching a old video of me quizzing you guys on, like, what's the number I should add? And you guys were just spitting this stuff out so quickly. No, I had to watch some videos because I was sending...
Just watch the archive.
No,
They got it.
I was sending some of the videos down to Derek because he wanted to have some, like, good samples of, like, teaching and stuff like that. So I had to rewatch some of the videos. But anyway, and you guys were spitting this stuff out. So what you do is you take the way to complete the square. I'm going to call that CTS, complete the square. Is you take this number over here and you divide it by 2 and you square that. So b over a divided by 2 is b over 2a. We cool? Come on, you guys. Don't let me wait every single time. All right.
There's a watermelon that sat in
Now,
the fridge for like
b
30
over
minutes.
2a, if I square that, I multiply it by itself, it's really
Strawberries.
b squared over 4a squared. Are we good?
Yeah.
And that tells me what I should add. That's why I put in those spaces. So I should add b squared over 4a squared. But I can't just go around adding b squared over 4a squared. I should subtract b squared over 4a squared as well. That's only fair. Okay? Now, the whole point of adding that b squared over 4a squared is so that I can take these first 3 terms and factor that. In fact, I'll tell you what it factors out to. It factors to x plus b over 2a squared. And I even challenge you, don't believe me, square it out. Like, multiply this by itself and you'll find that you'll get these exact first 3 numbers. By the way, I still need that a out in front, and I still have all of this junk out over here that I didn't, that aren't included in those 3 numbers. So I've got the c over a minus b squared over 4a squared equals 0. Are we cool? We good? Bad? Ugly? What? All right.
Sad.
So now what I'm going to do is I'm going to multiply that a back in there. So I'm going to put the a into this term, and by the way, this is 1 term, 2 term, 3 term. I'm going to put the a into that one, the second one, and the third one. So I have a x plus b over 2a squared plus c minus b squared over 4a equals 0. All right. I'll give you a second to kind of like process what I did. Tell me whether or not you can kind of follow it. All right, kind of, and I'm going to tell you right off the bat, you're not going to get this when I show it to you the first time. Okay? Brandon and Diamond might get this because I'm showing it only because they're seeing it the second time.
Oh yeah.
I'll tell you what,
like
when
guys
they
on the
first saw it, they were like,
What?
"Where is he going with this? What's the point?" Okay.
You are not alone.
We'll get there. We'll get there. So I mean, don't feel that you have to understand everything. If you're confused, then you're actually at a good place right now.
Yep.
All right. Let me finish this off. I want to solve for x. I want to get x all by itself. I have 3 terms, and so I want to put every term that doesn't have an x in it onto the other side. That's the first game we play. So I'm going to move the c over, and I'm going to move the b squared over 4a.
Bye-bye.
So I have ax plus b over 2a squared equals b squared minus 4a, or b squared over 4a minus c. Are we cool with that? All right. Now, why don't I do this? I think at this point, I'm going to divide the a. I want to get rid of this a right here. So I'm going to have x plus b over 2a squared equals b squared over 4a squared minus c over a. You see what I did? All I did was I took that a that was being multiplied on the other side and I divided both terms on the right side by the a to kind of get rid of it. I divided it out. We good? Adriana, I need some response from you. Kingston,
What's
come
A
back.
divided by A?
What is that?
A divided by A.
A divided by a is 1, and that's the whole point. I mean, that's how I got rid of the stuff on the left. Because if I divide this whole term by a, then that just, that cancels out those a's. But then I divide this by a and divide that by a, that's where I got c over a, and that's where I got b squared over 4a squared. All right. What I'm going to do is, before I take the square root of the left-hand side, I want to try to combine fractions. The two fractions on the right side. So what's missing from here is a 4a. So I'm going to multiply both the top and bottom by 4a. We cool? And then what I'll have is x plus b over 2a squared equals, now they have a common denominator. So that would be b squared minus 4ac all over 4a squared. I'm gonna ask you, good, bad, ugly? I don't think that any of you are ugly. I can't see you, but I'm just saying, are you good? I know this is ugly. The math is ugly. All right, okay. Now what I'm going to do is I'm going to square root both sides. X plus b over 2a equals, and when I take the square root of both sides, I always need to add in a plus or minus. Now, what is the square root of the stuff in the denominator? Are you sleeping?
No.
What is the why do you have your sunglasses?
Just no. I don't know, 2A.
The square root of the stuff in the denominator, you take the square root of 4, that's 2. The square root of a squared, that's just a, so it's 2a. We cool?
The water. Is the water on? I got you started.
Alright. Now all I'm going to do is I want x all by itself, so I'm just going to subtract minus b over 2a. So I have x equals negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. And that is the quadratic equation that the book gives you. The only difference between their quadratic equation and mine is, since they have the same denominator,
It's that there weren't 2 parties or 2 times that the party ended.
I just put it over the common denominator. That's the difference. But there we go. That, my friends, is quadratic equation. And really, all I did was I did a little bit of algebra, like Algebra 1 stuff, and
No, he didn't, John.
I didn't come up with this. This isn't my creation, Maybe I might have come up with something like the way to explain it, but this isn't like Mr. Daldy's. This is called the quadratic equation. If I came up with it, I totally would have called it the Mr. Daldy equation. All right?
Maybe some dude named Quadratic.
Yeah. Maybe some dude named Quadratic came up with this thing. Weird last name, dude. All right. But here's what I'm saying is, all we used was completing the square. That's the only technique that we used. We good? And so that's why this stuff works, is because I told you completing the square always works. That's why I spent 4 weeks teaching you completing the square, because I want you to understand where this comes from. I hate magic. I'm not a magic kind of person. Mathematics is not magic. It makes sense, it comes from stuff, and it's not a bunch of equations you just plug stuff into. All right?
My favorite magic trick is 52. Where you're like,
All right.
and the cards.
So let me kind of, because I you know what, I really need to get through a lot of this stuff because we don't have a whole lot of time.
Oh my
So here's some of your homework, and read the stuff. Let's see, is this a different? Okay, here's another one. All right. So
Computers are tired.
Let's try this one.
Hi,
Ready?
John. Thanks for calling.
Alright.
Thanks for What page
What?
is this?
This is page 10. Alright, ready? Function f is a quadratic. The function is given below symbolically in 3 different forms. Okay, that's nice. They've already given us all 3 forms. Are you drawing? You totally are. Do you even have your packet printed out?
No.
Turn to a new page, start writing this stuff down. Okay. So, x minus 4, x minus 2, that is one form. That is still a quadratic, even though there's no specific squared form, right?
I just ignored that.
Oh, okay. All right. Even do you guys see how this is still a quadratic?
Yep.
All right. They also said, okay, the same equation in standard form is x squared minus 6x plus 8. Cool. The same equation in vertex form is x minus 3 squared minus 1. All those 3 different things is just 3 different ways to look at the same equation. Like I said, it's the same person, they're just wearing 3 different outfits. If you were to multiply out, if you were to FOIL this thing, or if you were to you were to FOIL that first term and subtract 1, I guarantee you'll get that. It will all be the same. It will all, you can always bring it back to standard form. Okay? So they did our work for us. They probably did completing the square to figure out how to do that. And then they also factored it. That's not that hard. If I gave you the standard form, you could have gotten the rest. Anyway, complete the statements below. Where's the y-intercept? Look at the 3. Where is the y-intercept? You say what?
8. Positive 8.
Why positive 8?
Because in the standard form, the last number.
What do you do? What do you do to
X equals
find?
0.
You set x equals 0. If you want to find the y-intercept, you set x equals 0. The easiest place to do that would be in the standard form. In fact, to be honest with you, that's the only place that the standard form is actually very useful in.
Yes, sir.
Does that make sense?
Yeah. You're supposed to fill it in.
Where are the zeros?
What zeros?
Where are the zeros? That's what I'm asking. The zeros of this function are at x equals. So
Fracted.
the zeros mean where is the x-intercepts? If you want the x-intercepts, you set what equal to 0?
Y.
You set y equal to 0. So, in this case, y is equal to 0. That means the f of x part. The f of x is also representative of the y. Set that equal to 0. The easiest way to look at that would be to look at the factored form. So where do they cross?
Positive 4 and positive 2.
Good. 4 and 2. You just look at that. Right?
Yeah.
May I ask why? Don't make it a big deal, but why are they positive? Don't make it a big
Oh, okay.
Because
deal.
they.
No, I'll tell you.
Oh.
Diamond, you can
Okay.
know.
Because when you look at this thing, you take the opposite of it. The opposite of both of them. No, both.
Okay, take it.
Where's the vertex of this thing?
Positive 3, negative 1.
Good. Positive 3, negative 1.
Sure, it's like choking me.
Yeah, dude, you sure
And by the way, what form is the easiest for that? To find the vertex, you should probably use the
Vertex.
vertex form. Right, and we know this because this is like the vertex form was the first thing I taught you. The vertex form was the first thing I showed you and said, let's look at this graph. How do we mess with it? And John ended up being really good at this. You take that parabola and that negative 1, this negative 1 right here, it will drop that parabola down 1 square. And that negative 3 will actually move that parabola to the right 3 squares.
Still not over.
So the vertex is at 3, negative 1. Very cool. Does the parabola open up or down?
Up.
Up.
It's a happy parabola.
Is it like is it abnormally
Nope.
shaped or is it just a regular
Just
parabola?
regular parabola.
And what would be the best way to determine that?
Standard, but all of them.
Standard,
Yeah.
but all of them.
Well, standard form, yeah, you just look at that number in front of there. There's no number in front of there.
Put all of them.
Vertex form, there's no number in front of there. Even factored form, if there were a number over there, then it would mess with the shape or the up and down, all that kind of stuff. But there's nothing out in front of there, so standard form. That's it. Or I mean, it's all of them. This. It's a up parabola normal shape. Cool? So this is kind of bringing it all together. If we were to graph this, we know that the parabola crosses at 0, 8. Wait, yeah, 0, 8. So it's 0, 1, 2, 3, 4, 5, 6, 7, 8. That's the y-intercept, right? You guys wrote this down. It's up a little bit. We also know that the zeros is at 4 and 2. So we have 2 and 4 right there. We also know that the vertex is at 3, -1. So right here. And we know this thing opens up. Darn, that's an easy thing to graph. You just kind of do one of these. Are we cool? So, I mean, you look at these and you can kind of just like, boom, I got it all. I understand it all.
Yeah.
All right. So let's see, what else are they trying to teach us? Okay, all right, here we go. Let's do this one. Let's graph this one. This is in standard form, okay? We're gonna try our best to graph it, or we're gonna try our best to kind of understand all the pieces of it. We cool? So it's in standard form. I have a question right off the bat. Can you tell me what the y-intercept is? -5. You just take a look at the standard form. Whatever doesn't have an x in front of it isn't going to die. Anything that has an x next to it, if you set x equals 0, it will die.
Okay, then.
Yeah, like killing puppies.
What if
As easy as killing puppies. Okay.
isn't easy?
You ready?
Because emotions.
All right. So, can you factor this?
No.
I would say I wouldn't want to. The reason why I wouldn't want it is just because of that 2 out in front. I hate factoring
No,
things.
It's because of the 5.
All right, find the 5.
Yeah.
I don't even think you could factor
Two
it.
isn't even a number.
But even if you could factor it, I don't like factoring things
Oh.
with a number in front of the x squared term.
I don't even know.
I'm just letting you guys know. That's not something I like doing. I'd actually rather you do the quadratic equation. Why don't we use the quadratic
Try to
equation?
use the quadratic equation all the time.
All right,
Oh,
so
I hate factoring.
let's try this. All right, so we got, what is A? If you were rather do the quadratic equation, tell me what A is.
Right, this is 2,
2.
and
Ooh.
then 10.
B is
C,
10. And
and
wait,
then
I want
-5
Adrian.
C. Oops.
-5 is C. I want Adriana to tell me. All right, anyway. What
thought you asked
is
her
the
to tell you the
quadratic equation? And this one I want Brandon to tell me since you can just talk to me about it.
Huh? What?
What is the quadratic equation? Can you talk with me? Can you
I
have
can
it?
tell you the story.
No,
Do you
don't
want
tell
me
me
to
this.
tell you the story?
Don't tell me the story.
So
Tell me the, no. Tell me the equation. Tell me what to write down.
Okay.
No, the story. He
No,
wants
I
to know
can't.
the
I can't
story.
think of it. I know it involves C's and B's.
I got it.
All right, fine. What is the story?
I
Number
got
2s
it.
and
Okay, well, tell me the story. I know you got it. Tell me the story.
what's the first part? Okay. Is it negative boy?
Negative B. Just give me the highlights.
What are you?
You were unsure.
Dive into it. He was they're unsure. Did you see her?
I know. It looked like a doggy paddle. Plus or minus.
We wanted to go to a radical party.
Radical.
We decided to go.
No. What was he being?
He was being a square,
B squared
so we missed out.
minus
Talking in 4 awesome.
4AC
The party ended at
2A.
I'm
Quadratic
just like
equation.
this on the bottom.
Practice writing that down. Okay? Alright. So, compare that to this. The B is 10, positive 10, so we're talking about negative 10 plus or minus the square root of 10 squared, which is 100. Minus 4 times 2 times negative 5.
Negative 40.
So it's
Positive
actually
plus
plus 40. Do you guys see how that works?
Yes, sir.
Because if you have minus negative 40, it becomes plus 40. The double negative cancels out. Okay. All divided by the number 4. So I have negative 10 plus or minus the square root of 140 divided by 4. These are almost nice numbers. The problem is 140 I don't think can be like square rooted.
Sucks.
we can kind of play this game. We can, and this is the part I didn't teach you online. So, and I spent a lot of time doing with the students on Tuesday, which was you can reduce that 140 down. You can simplify that a little bit. Let's try that. If we simplify 140, the square root of 140.
Right. Not Tuesday, Mr. Dollar.
The square root of 140 is, oh yeah, it was Wednesday.
It was Wednesday.
All right. The square root of 140 is what?
I don't know.
Well, the square root of 140 is, you can break that down into two numbers being multiplied by each other. I would say 4 and...
100.
No, crap.
No. What's 140
Wait,
divided by 4?
14? No, it's
No.
not.
No, that's 10 times 4. Or 10 times
14.
14. What's 140 divided by... So 100 divided by 4 is 25. 40 divided by 4 is 10. So 35. Are we cool with that?
Okay.
Right?
Sure.
Dude, you have a calculator in your computer.
Well, 4 times 35 is 140. Are we cool with that? Yeah? Agreed? Why did I choose 4?
Because 4 is a perfect square.
Because 4 is a
Well,
perfect square. It's a number that you can pull out of that square root. Because the square root of 4 is actually 2 square root of 35.
You could have done 100.
No, you cannot do 100 because 140 can't be divided by 100.
Look at that.
Does that make sense? Alright, so anyway, I can replace this square root of 140 with 2 square root of 35. And I'll have negative 10 plus or minus 2 square root of 35. Watch this, watch this, watch this, watch this, wait, watch this. Now what I'm going to do is make this negative 5 plus or minus the square root of 35 over 2. What did I do?
What? You divided the negative 10 by 2.
I just divided everything by 2.
He divided everything by 2.
I divided by the 10 by 2, the 2 root 35 by 2, and the 4 on the bottom by 2. That's all I did.
Okay.
You get that?
Yep.
You see that?
Yep.
You're going to have to do this on your own.
Yep.
All right. Okay, you know what? What else is it we're trying to teach you?
You know, when you can't think of what you're supposed to teach us next, I think that's when class is over.
No.
Because you taught us all the control for the day.
No, because we got 30 minutes, a little less.
Yeah. And to be honest with you, I really want you to make sure that you know how to do this. All right, let's try this. Sketch a graph of a parabola, any parabola, in which the zeros have values equal to 3 plus or minus the width of your thumb.
What?
What?
Are these instructions?
Okay,
Wait,
fine.
Whoa,
Sounds silly, but just do it.
Where are you?
I'm on the bottom of page 10, I think. Or there, that's it. Page 11. I'm on page 11. Okay. 3 plus or minus the width of the thumb. Fine. Try to make the width of your thumb part
It's a
fairly
centimeter.
accurate of your graph. Okay, fine.
Centimeter.
So what we do is we have 3, but that's not where I want the parabola to cross. I want it to cross at. I'm putting my thumb on the computer screen.
Yeah.
There. That one. And I'm putting my thumb on the computer screen. And that one.
Oh, shoot.
That's as accurate as I can get it. We cool?
Yeah. We got a troll over
That's
there.
such a weird, it's such a weird instructions. Why?
I don't know. I really don't.
Okay, wait, I'm gonna copy.
And I don't even know if my my thumb is bigger, abnormally big or small.
Probably.
Or you have an average size thumb?
I have an average size thumb.
All right. Why don't you put your thumb
Grandy has an average size.
right on this? So put it on that side of the 3. No, that's on top of the 3.
No one's on that side of the 3.
No, it is not.
I'm sorry, I'm at an angle. Okay, there. Now it's
Okay. All right, your thumb is only a little smaller than mine.
I have an average size thumb.
All right, fine. So, what you guys see on the computer screen is Mr. Dalday's freakishly large thumbs.
Excuse you, mine is the
same
same
I thought you have an average size and mine is just a little bigger. All right, anyway. Can you identify where the location of your vertex is?
Joanna says no, you don't.
No, she said that way later.
Okay, I
She
mean
was
something
earlier.
about my thumb being average.
If not, can you at least identify one value for this ordered pair? Do you know where the
3.
3 what?
3 is your vertex.
Just 3.
That's your x vertex. Your 3.
Okay, the x coordinate is 3. What about the y coordinate?
I don't know. Probably 0. Because it's on the x thing.
Well, it can't be 0.
Why not?
Because if it's a
That's
parabola,
really
it will
it.
look something like this, and it will cross twice. If it were 0, that means it would have crossed a third time. You're not dealing with a parabola then. Does that make sense?
Well, then where would it have to be? It says if not, at least identify 1.
Well, look, what we're saying here is, look, you can draw a parabola that looks like this, right? And its vertex is at 3 comma something, right? Something big. You can also draw a parabola that looks like this. And its vertex is at 3 comma something small.
What says that it's an unhappy parabola?
You can even,
Where does it say it's an unhappy one?
Where's
it doesn't, that's the point that we're trying to make here, is that it could be this parabola. It could be this parabola.
Yeah, so it's
All of these have a vertex at 3 on the x-axis, but the y-coordinate you can't really tell. So when I ask you, can you identify where the location of your vertex is? The answer is no.
Can only do 1.
But you can tell me where one part of the vertex is. You can tell me that the x-axis is guaranteed, spell barons, 3. The y-coordinate I couldn't tell you. You would have to tell me more information about that parabola if you wanted me to tell you what the y value is.
That's what I guess, and I just make a random problem. Like, where did this go? Oh, okay, let's say it's roughly like 4. Cool.
It looks like
I think the rest of this you can do. All right.
Gives him a scale 5 to 9. Somewhere in there.
So they kind of go over this with you here. Use complete the square form. All right. Because I think I gotta actually get through like a good chunk of this curriculum. All right, and then they have these stations, which
they just don't go away. There's like 8.
and they have homework. All right. Okay, I'm on page now
28.
28. Let me finish off class, okay? Solve the quadratic equation below using the quadratic formula. Notice that it is not in standard form. Not yet in standard form. Set it equal to 0. Just as you did with the factor method, the equation must be first set equal to 0 before proceeding. Find both the exact solution and the solution rounded off to the nearest hundredth. Okay, alright. All you do is this.
4 minus 7.
Well, first of all, is this in
No.
standard form?
You
If
need
it
to
were in
equal
standard
0.
form, it needs to equal 0. So all you got to do is take that 7
-3.
and put it over to the other side. So you subtract 4 minus 7. Why don't you minus 7 from 3x? Or 3x squared?
Because the 7 doesn't have an x squared. Or
Why don't you
x.
minus it from negative 6x?
Because it doesn't have an x.
Right. We're
we're just-
discriminating here. We're keeping the x's, x squareds with x squareds, and the x's with the x, and then the
We only
the
like
losers who
4.
don't have an x attached to them, they can hang out with each other.
3x squared
So this is 3x squared minus
3.
6x minus 3 equals 0. Fine. What is a? Wait. Adriana. What is a? Adriana. I'm looking at you. I'm looking at your name.
No.
A is not no. Okay, fine. I'll let somebody else online answer this.
Oh,
Online.
Thomas is here. Hey, Thomas.
Thomas, give it to me. Come on, man.
Noah Brownie.
What is A? You know, it doesn't
It's
help
like the
when you do
weirdest-
this.
I know, because it could be like this.
What is A?
Why isn't anyone typing it?
Please type something.
Anybody.
Wake up. 3.
Hey!
Hey.
How did you get that? No, I'm just kidding.
Hey man, that was difficult.
Struggle was
Okay,
real.
wait. I'm gonna let Adriana know because I want you, Adriana.
I'm not doing it.
The A was whatever number was in front of the x squared term. You got that, Adriana? Say yes or no. You understand where I got that A from? Okay, good. Oh, Thomas, wait, I was
Thomas,
gonna
stop.
ask for
Thomas,
B.
stop.
Oh, Thomas.
Hey,
Thomas
It's
got
side
on
note.
top of it.
Thomas got B wrong.
And C.
And C.
And C.
What is B and what is C? Okay, I know. What is B? What is B? I know you know how to write down the equation. What is B, though? And this is for you guys online. It's not 6x.
No.
Oh my goodness. Chillax, my
Getting
friend.
agitated.
What is B? Okay, all right, let's go.
I'm missing a finger. I need assistance.
But not 7.
Where is it?
No, what you're doing is you're just pointing. It's this.
No.
It's this.
Okay, like this then. Oh, I got you. Go back.
Now maybe we go like this, right? This is positive.
Oh, okay, like this, guys. Like,
Oh, yeah, that makes sense.
Boom!
There you go.
There we go. It's the stuff in front of the x. Now, if you compare that to the ax squared plus bx plus c, that b needs to be -6. All right? Now, this is for Adriana, specifically Adriana. Look at this equation. What is c? No,
I'm not
no,
gonna tell her
don't.
because I love her.
What is c? I want you to get this. -3. There we go. I think she private chatted me. Yeah. There
Oh,
we go.
I was like, does it even show it on
Yeah, it's not showing up there. I was
like,
so
I'm
confused.
Such a
Yeah.
retard.
No, she got it. Exactly. Very good. Awesome. I don't know why you private chatted me because you were exactly correct. And I wouldn't have teased you if you were wrong. Okay? I'm not trying to pick on you. Do you guys feel like I pick on
A
you?
little bit.
All right, I'm sorry.
I don't
Alright.
take it personally.
So, let's write down the quadratic equation. -b plus or minus the square root of b squared minus 4ac all over 2a.
I'm so good I did it without needing to write it down and
All right.
numbers.
The -b is +6 plus or minus the square root of
Who's that?
-6 squared. -6 squared is what?
Why, thank you.
What is -6 squared?
It's
I have all this on the
36.
cord.
36.
36 minus
36.
minus 4
36.
times a times c.
Negative 36.
So it's
plus 36.
Positive 36. Do you guys see how that worked? Do you
No.
understand where I got that
Not yet.
positive 36?
Over 6.
All divided by 6.
Sir, you're forgetting your negative.
What do you mean? Which one?
And, the B, negative B. He was a negative boy.
No, I didn't forget a negative. I wrote exactly the correct answer down. You figure out what happened to that negative. Do you understand what? Do you guys understand what the question that Diamond has?
I got it.
She's like, why is that not -6? Why?
Should I explain?
You can explain. Go for it.
Because the B is -6 already, so the negative and the negative is the positive.
I'm plugging -6 in for B. So I have -6, which basically just means +6. I didn't even write that. All right, anyway. This is 6 plus or minus the square root of 2 times 36. All over 6. Why did I not write like 72?
Because 36 is a perfect square.
Because after I got 72, what I would have done is like think, well, what can I divide out this thing so that I can make it a perfect square?
Just save
I was
yourself.
like 36. Oh, hey, 36 is a perfect square. You can make that a 6 plus or minus the 6 times the square root of 2 all over 6. Because the square root of 36 is just regular 6. Cool? All right. And then I'm going to do this. Pay attention. 1 plus or minus the square root of 2.
Yep.
You understand how I did that?
Yep.
Everything in there had a factor of 6 in it. I can divide everything by 6 and not change anything.
Yep.
There we go.
Yep.
So I'll tell you right now, the square root of 2 is 1.41, I think. So it's 1 plus or minus 1.41. How did I do that? Beep, beep,
Just
beep, 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 beep.
remembers it.
Yeah, it's just
Boss.
no. You
Over the years, you remember things.
yeah. You use it
Math
enough, you
teacher.
just remember it. So like I memorized the square root of 2. I think it's 1.41. All right. So what's 1 plus 1.41?
Tired.
So the answer is 2.41. And what's 1 minus 1.41? The answer is negative 0.41.
Oh.
Because it's 1 minus 1.41. I'll tell you what, why don't we Desmos that sucker and see if it works. That was 3x squared minus 6x minus 3. Oh wait, not plus negative 3. There we go. Alright, let's see.
Oh snap.
Negative 0.41, 2.41.
We just did math.
That's it. Booyah. Mm-hmm. Alright, anyway. We cool? What do you guys think about this quadratic equation?
Yep.
Like, I'll admit to you, I'll totally admit to you, it's hard to understand. It's hard to, like, understand where it comes from. And I think that after only seeing it, like, a whole bunch of times, we're not able to really derive it. But no, what I want you to take from this is this. I don't ever expect for you guys at this, in this grade, for you guys to do what I did.
Wait.
In this grade, I don't ever expect for you guys to do this. Derive the quadratic equation. It looks ugly. It is ugly. Huh?
Prove.
Yeah, prove it. I don't ever expect you to do that. But what I do expect you to do is know how to use it. You know, you take out the A, you take out the B, you take out the C. And there's even tricks to the quadratic equation. And later on, I'm going to show you like how to look at something and say, huh, that you can look at that and say, that parabola doesn't even cross the x-axis. See, what happens then? We haven't solved those problems. Does the quadratic equation work? Think about this. The quadratic equation tells us exactly where the
doesn't work.
parabola crosses the x-axis. And I actually told you that the quadratic equation always works. So what happens
You lie.
when the parabola doesn't even cross the x-axis?
You lied.
You're going to get in trouble with that phone. I'm telling you now. Like, I'm going to take it away and give it to Mrs. or to Kim. She's not very cool with giving phones back. Just let you know. All right?
She likes to get.
Now give me that look. You brought this upon yourself.
Don't give it. Don't give it.
Okay, alright. So,
Don't give it.
okay, alright. We only got 10 more minutes of class. Just hang out, okay?
Are we gonna do
But my question is, what happens? What do you think happens? Do you understand the question?
Yeah.
We have
I think
parabolas.
it doesn't happen. That's what happens.
If a parabola crosses
It's
at nice numbers, then we could have
Probably
factored
zero.
it. If a parabola crosses at ugly numbers, then we couldn't have factored it, but we can use the quadratic equation. And like you said, you don't like factoring. So you probably want to use the quadratic equation all the time. And you know what? That's perfectly fine. It might take you a few seconds longer than the person who will factor it. But, you know, but hey, you know that this will work. It is a tool that you can come back to. What happens when because there are parabolas that don't even cross the x-axis.
I have
You
no
guys-
idea. Let's try it.
I mean, doesn't that bother you?
Yes, it does. Because you said it works all the time.
And I'm telling you, it works all the time. So what do you do if your parabola doesn't even cross the x-axis? How do you deal with that? I think that's just crazy.
Crazy generous.
All right. I'll tell you what. I will not show it to you today. I will show it to you in the next.
Wednesday.
Actually,
No, Tuesday, guys.
I'm going to show that kind of stuff to you in the next couple of weeks. All right? It's not even going to be a topic that we cover yet. I think it's going to be chapter like 10. So we're on 8 now. We cool?
Yeah.
See,
Alright, I think that I got through enough of this stuff to really kind of give you a head start on your homework.
That was slick.
Do you guys think you got your homework?
Yeah.
You guys can do this?
Yep.
It's not even that bad. You just
So,
kind of like take it.
Like, is it, you know, like when you have the due date and then you have like the final due date for everything?
It's
is it
really due
okay?
on the final due date.
Okay. So I was gonna say, is it okay if I put everything on
Paula
the due date?
procrastination.
Yeah.
What? I mean, I didn't. I'm not
So,
gonna.
alright, I'll talk to you guys later. I'm done. I've got my
Finley.
whole thing done.
Finally.
Okay, bye.
Whoa.